Hello and welcome to the study of matrix. We have seen that matrix is an arrangement or an array of numbers. So we are looking at singular matrix. A matrix is seen to be singular if its determinant is equal to 0. Here we are considering matrix A, which has element A, B, C, and D. So if the determinant of A is equal to 0, then that particular matrix is seen to be singular. A singular matrix has no inverse. Why? Because when you have is equal to 0, so a number divided by 0, we say it is undefined. So now to identify whether a matrix has an inverse, all what you do is to get the determinant. For example, determine whether the following matrices have inverses or not. So you are given A. You are given matrix whose elements are 3, -2, -7, and 5. The question is you determine whether they have inverse or not. Then you have 4, 3, 1, -2, 0, 8. Then you have part C. You are given the element -2, 4, 1, -2. Then in D, the element of D is -1, 0, 0, -1. So the question is to determine whether they have inverse or not. So we begin with A. A is a square matrix. You have element 3, -7, -2, 5. So determinant of that matrix will be given by the product of the main diagonal, which is 3 times 5, which will give you 15 minus -7 times -2 will give you 14, positive 14, which is equal to 1. So now, since the determinant is not equal to 0, it means that the matrix is not singular. We say it is non-singular. And we can get the inverse of A. So inverse of A will be given by 1 over 1. We change the element. This is 5, 2, 7, 3. So to get the inverse, what you do, you switch the element on the main diagonal. Where you have 5, you write 3, and where you have 3, you write 5. Then you change the signs on the leading diagonal as shown there. So this matrix has got the inverse, and because the determinant is not equal to 0. Part B, we have this matrix here. This matrix is not a square matrix, and so has no inverse. Then we come to part C. Part C. Our matrix in part C is -2. We have -2, 4, 1, -2. Now, then the determinant here, will be given with the product of the main diagonal, which is -2 times -2 will give you 4. 4 times 1 will give you -4. 4 times 1 is 4. So, which is equal to 0. So determinant, it is the product of the main diagonal minus product of the other diagonal. So in this case now, our determinant is 0. So the matrix has no universe. Since now we know that the reciprocal of 0 does not exist. It is not defined. Finally, the matrix indeed it is -1, -1, 0, 0. So for part D, we have -1, 0, 0, -1. The determinant of this matrix will be given by product. There, -1 times -1 will give you 1. 0 times 1 will give you 0, which is equal to 1. So the inverse of this matrix will be the same matrix. Will be the same matrix when you get the inverse. So we have an example here. You are given that this matrix has no inverse. So the question is, you get the values of x for which this matrix has no inverse. So if the matrix has no inverse, it means that the determinant is equal to 0. So to do that, what we are going to do, we are going to get determinant, which is given by product of the main diagonal, which is 2x times 1, which will give you 2x, minus the product of the element on the other diagonal. 2 times x will give you 2 times x squared will give you 2x squared. This is equal to 0. Here we can factor 2x outside, so you have 2x, so that you can be left with 1 minus x, which is equal to 0, meaning that our x is equal to 0, or 1 minus x is equal to 0, meaning that our x is equal to 1. Is equal to 1. So we can check when x is equal to 1, when x is equal to 0, sorry, our matrix will be 0, 2, 0, 1. The determinant here will be equal to 0 times 1 is 0, minus 2 times 0 is 0. So you can see our determinant is 0. When x is equal to 1, 2 times 1 will give you 2. Sorry. Yeah, 2 times 1 will give you 2. 2. 1 squared will be 1. 1. That way. So the determinant here is equal to 2 times 2 will give you 2, minus 2 times 1 will give you 2. Sorry, it will give you 2, which is equal to 0. So clearly now the values of x, whereby that matrix is not defined, is equal to x is equal to 0 or 1. Those are the values of x, whereby that matrix has no inverse. So thanks so much for watching this video concerning the matrix. For other video tutorials, you can remember to check my YouTube channel so that you don't miss a single video which I upload every day for us.